Hello, everyone. We are going to get into word problems. So we've had all different things in chapter 5 talking about these different linear systems. I'm going to turn my phone to silent. Talking about how to solve them with substitution, with elimination, solving them by graphing. And now in this point of the chapter, we kind of move into some different type of topics. So first off, we're going to look at different word problems that have to do with systems, and we can use any of those methods that we've talked about before in order to solve them. We're going to do a quiz that's just on elimination method of systems and word problems. We're going to do that either on Wednesday or Thursday, depending on if you're A day or B day. And then after that quiz, we're going to get into graphing inequalities. And that's going to about wrap up chapter 5. And I think we'll have just enough time to get through chapter 6 before the end of the trimester. Okay, so hopefully we're working through. If you have any missing assignments, if you have any other quizzes that you need to get finished, make sure you're working through that as we're going along through all this. You have this, hopefully you now have that note packet that we had before. Right here, it's not immediately after solving by elimination, it's more toward the back of the packet. But we're here, it says like solving real life problems with systems notes. You have these in that notes packet, right? So we now that we have these different techniques that we've used to solve our systems, now we can set up these word problems with two variables. Okay, so we can set these up where we have two variables and we have two equations, because now we know how to solve something out if we have two equations. We can use substitution or we can use elimination. Right. I'm mostly going to show you how to do this with elimination, just so we get a little bit more practice with elimination, because that's what's going to be on our quiz later this week. Right? So we need to make sure that we define each of our variables. So, okay, let x be this, let y be this, so we know, okay, what each of our variables are. A lot of times with word problems, we can be super creative with like, okay, we can let, P be the peanuts or whatever it is. But we want to make sure that we're just using x and y for these systems. Because that's what we're used to with systems. It's just going to be the easiest if we stick with x and y for these. So that's what I'm going to do. We're going to write out our system. So remember, system just means two equations. Technically, we can have systems with more than two equations, but if you see a system with more than two equations, it means you're in algebra 2. So don't worry about those. Use substitution or elimination. You've always got to show your work with those. And then answer using labels. So don't just give me an answer like x is equal to this, right? If the question was asking you, how many sweatshirts do you need to sell? You want to tell me 32 sweatshirts or whatever. You want to say what the actual phrasing of the question. Don't just give me x is this, y is this, because that's not what the original equation was asking you for, or the original question, I should say. Okay. So a lot of times we can kind of fall into two different main categories. Okay, so sometimes we have this slope-intercept form. So usually if you have a rate of change and a starting amount, so the one I always like to use is you're renting the car. So you start off, it says it's $100 flat fee and then $2 per mile. Okay, something like that, where you have one starting value and then a rate. You can put that into slope-intercept form. Or if you have something that's more like you're doing a fundraiser and you're selling bracelets and you're selling t-shirts. So, okay, your number, your t-shirts are $2 and your bracelets are $5. I know these numbers may not make sense. I'm just making this up. All right. And then you make $200 at your yard sale or whatever I said it was. Okay. When you have two different rates, you normally use something like a standard form where you're saying, okay, I'm combining two different totals. Okay. The 2x and the 5y in order to get one big total. Or, okay, slope-intercept is more when you have one total and you have a rate and a starting value. So you kind of just have to look at the problem, see what type of format makes sense. Some people, word problems come easily to them. They can look at it and just kind of, it's intuitive how things fit together. Some of us need to look at word problems a little bit more in depth. It takes us a little bit longer. Don't panic, don't stress out. There's not too many different kind of variations on these that I'm going to show you. Okay, so let's just hop in to one of these. So we've got Kristen. She spent $131 on shirts. Okay, so fancy shirts cost $28 each. Okay, so I like to chunk each little bit of information. Okay, fancy shirts are $28. Plain shirts are $15 each. Okay, if she bought a total of 7 shirts, how many of each type did she buy? Okay, so I'm going to just tell you right now, a lot of times people aren't sure what information should go in one equation and what information should go in the other. Okay, this is a pretty common type of problem where you have a total amount spent and you're trying to figure out how many of each, you have 2 different categories. How many of each do you have? So first off, you want to make a money equation, okay, where you're saying, okay, I have the total amount of money that she spent, and I know that I'm going to say, okay, fancy is X and plain is Y. Okay, we don't want to use like F and P. We're used to using X and Y for systems. Let's just stick with that. Okay, so we know that every fancy shirt she buys is $28. Okay, so 28 times the number of fancy shirts plus 15 times the number of plain shirts. She ended up spending her total of fancy and her total of plain added together to get 131. Okay, so that's what I kind of think of as like the money equation. You're totaling up how much money was spent, and then I think of like a number of items equation. Okay, so if you kind of struggle with what information should go in what, I usually put all the totals of the money in one, and then I say, okay, well, I know that the fancy shirts plus the plain shirts, okay, number of fancy plus number of plain, we have a total of 7 shirts, so I know that X plus Y is equal to 7. That's almost always how I would really break that type of information down. I could use substitution, but since you have a quiz on elimination coming up, I'm going to use elimination. Okay, so if I'm trying to think, let's just use X just for the fun of it because it's pretty much the same either way. If I wanted to get X plus Y equal to 7, if I wanted to get my X to cancel, I'm going to need to multiply this whole equation. Okay, I've got positive 28 right there. I'm going to need to multiply this whole equation by negative 28. Okay, you always want to make it like the opposite sign from what you already have. Okay, so multiplying all of these terms, so I'm going to end up over here, just trying to make sure I have enough room. I've got negative 28 minus 28y. I'm sure some of you can do 28 times 7 in your head, but I can't. 196. So negative 196. Great. And then I'm just going to keep that top equation exactly the same. I didn't multiply it by anything. Oh, I forgot my x right here. Negative 28x minus 28y. Okay, I've got 28x plus 15y equals 131. So I'm going to go ahead and use my elimination method. I'm going to combine all of my like terms here. All right, so 28x minus 28x, I get 0x. And then positive 15y minus 28y. I'm going to end up with negative 13y. It is equal to 131 minus 196. I did put that in my calculator just to make sure I wasn't doing goofy math. Negative 65. Okay, I know my 0x is going to get canceled out, so I'm going to go over here where I have more room. Okay, I've got negative 13y is equal to negative 65. And when I divide that out, I want that negative 13 to go away, so I divide that out. I get y is equal to positive 5. Okay, so just like before, I can't just have y. I don't just want the number of plain shirts. I also want the number of fancy shirts. In this equation, it's pretty obvious which, or this problem is easy. It's easy to see which equation is simpler to plug it in. It's this x plus y is equal to 7. All right, pretty simple to solve that one out. So x plus y is 5, equal to 7. I'm not going to make you write out the minus 5. X is equal to 2. All right, but don't just say y is equal to 5, x is equal to 2. And in this one, I wouldn't even put it in the ordered pair of 2, 5. I would say 2 fancy shirts. Okay, remember, x was our fancy, and then 5 plain shirts. All right, you always want to put it back in the terms of your original problem. Okay. So let's go ahead. I want to do, I'm going to skip to C. I'm going to see how much time that I've taken up. If I have time, I'll go back to B or D, but C is a different type of problem. So I just at least want to make sure I do one of each type. Okay, so I begin with $90 in my savings account. Okay, and my friend begins with $35 in her savings account. So already kind of think about this keyword, begin. All right, to me, that would start flashing an alarm bell in my head. The word begin sounds an awful lot like a starting value. So this very well might be a slope-intercept form problem instead of what we just did. That was kind of that standard form that, see how this one was kind of in the x plus y equals number. This other one with the starting value is probably going to be as y equals mx plus b format. Okay, so let's see what the rest of it looks like. Okay, I begin with 90 in mine. My friend has 35 in hers. I am going to deposit $10 into savings each week, but my friend is going to deposit 15 into savings each week. So how long until my friend and I have the same amount, and how much money will we have then? Okay, so first off, I need to use my pen instead of the highlighter. With this one, I would break it into me and my friend. I'm going to do the one equation here and one here since I'm doing elimination. I didn't realize when I was setting it up, I was going to do elimination and it kind of looked goofy. So me and my friend. I'm going to use x and y. I'm going to say that y is the total in my bank account and x is the number of weeks. Okay, because this is what these equations are going to look like. I have this starting value of $90. Okay, so I know that's my starting value, my b, my y-intercept, whatever I want to call it. Okay, so I know it's going to end with plus 90. And my rate is $10 per week. It's 10 times x. Okay, so x is equal to weeks. And that's going to give me, it's going to be equal to y. Okay, y is the total amount of money in my bank account. That makes sense, right? The total amount of money in my bank account is equal to 10 times the number of weeks it's been plus my starting value. Okay, my friend is the same. Her total in her bank account is going to be, she is going to put in $15 a week, and she starts with $35. Okay, so we want the place where our y values are going to be equal to each other. Okay, I know I said I was going to solve everything here with elimination, but to me, this problem is so much easier to solve with substitution. I'm going to show you substitution with this one. Okay, because look at what I'm trying to do. I'm trying to figure out where both of these y values are equal. Okay, well, if I know that this y value is equal to 10x plus 90, I can just go right here and say, okay, well, this y is equal to 10x plus 90 is equal to 15x plus 35. Okay, so then we can just solve this out like any other equation. I can say, all right, first off, I'm going to get all my x values on one side of my equation. So I'm going to get rid of this 10x. I'm going to subtract it. Okay, so I'm going to get 90 is equal to 5x plus 35. Okay, subtract that. I end up here, I think that should be 55 is equal to 5x. Okay, divide by 5, and I get x is equal to 11. Okay, so after 11 weeks, we have the same amount of money in our bank account. All right, and then let's plug it in. I don't really care which one. Let's plug it into my equation. So y is equal to 10 times 11 plus 90. Okay, so y is equal to 110 plus 90, which is going to get me $200. Okay, so again, I don't want to leave it as x is this, y is that. That's not the way our original problem phrased it. I want to say after how many weeks? 11 weeks. We both have $200. I'm glad I put my phone on silent. My mom is a huge Chiefs fan, and she has not stopped texting me. All right. After 11 weeks, we both have $200. Make sure you always put it back into the phrasing of the original question. Okay? I feel like this has been a long time for me to talk about word problems, especially after I gave you that crazy long video last week. I think B and D are the other types of problems. So how about we do those in class so we don't have to repeat the same problems on the video as we do in class. And I will see you on Monday or Tuesday. Again, just be ready either Wednesday or Thursday to take that quiz. And we should be all good to go. I will see you guys tomorrow.